It's that kind of lifestyle in the player's paradise. Oh, hey. All right. For this remote viewing video, we are covering in Chapter 9 Chemistry. We're looking at percent composition, the idea behind it, and how you can calculate it. Okay? So, now, if you don't have your notes, you can always go to your downloads section. It says notes, percent composition and worksheet. So I took the worksheet that we had and I took out I just put on the percent composition part of it. Okay, and now back to our scheduled programming. So in the percent, when we talk about sales, like 50% off everything, every retail store at Ontario Mills has this percent discount at the window. Guaranteed, because any store that doesn't have it won't be there for very long. People love bargains, people love discounts, so it's a good skill to know about percent. But percent composition, okay, so it shows what percentage of the total mass comes from each element. Okay, that's kind of important. We may go back, way back in first semester, the law of definite composition. The ratio of elements in a compound is constant for every particle in that compound. In other words, in water, the ratio is always 2 hydrogens to every 1 oxygen. In sodium chloride, 1 sodium, 1 chloride. It's always been that way. It's always going to be like that. That's the law of definite composition. Now, when we look at something like percent, we got to think about part over whole times 100. Because that's really what a percent is. So if you got one of those soccer thugs out there that they attempted 10 goals in their last soccer game of the season and they got 9 goals in their 10 attempts, that's 9 over 10. The part being 9 over the 10 whole times 100, which becomes 90%. Okay? Hey, good one, Miles! All right. So, there are 6.72 grams of hydrogen in 60 grams of water. What is the percent composition of hydrogen in water? Okay, so we know about the part over the whole times 100. So they gave us 6.72 grams of hydrogen over 60 grams of water times 100%. Don't use the percent key on your calculator. Messes up everything. So when you divide this out, you get 0.112 times 100, and that gives you 11.2%. Yeah, so hydrogen as part of water is just a little over 11%. So, whoops. Yeah, so what happens if we find percent composition using empirical formulas? Okay. When you look at that, the mole ratio has to be changed to a mass ratio. It gets converted, okay? So how many grams of hydrogen are there in 1 mole of water? How many grams of oxygen are there in 1 mole of water? Okay, well, let's look at water. You get 2 moles of hydrogen atoms for every 1 mole of oxygen atoms, and you convert that to mass, okay? I personally think there's an easier way to do this. And you may remember the number of grams per mole. Right. So you got 2 hydrogens, each one is 1.008. Now you'd say, but wait. You said on the periodic table is 1.01. You're right. They're just taking this out to another decimal place. So chill. You got this. Okay, so 2 times 1.008. Okay, and we get 2.016 grams of hydrogen. We got 1 mole of oxygen, that's 16 grams per mole, okay, and there's your 16. So that's how much hydrogen we have, and that's how much oxygen we have in 1 mole of water. Okay, so our total mass is 18.016. So we can say take the part divided by the whole. Here's the hydrogen part, 2.016. divided by 18.016 times 100, and that gives us 11.19% hydrogen by mass. Okay, we can do the same thing with the oxygen. Take 16 divided by the 18 times 100, and we walk away with almost 89%. Okay, So that's the basic idea behind percent composition. So when they all add up, they should equal to 100%. Fairly straightforward stuff. Now, let's take a look at some notes here, because on your notes I included part of that worksheet. Now, hey, if you do have that worksheet, great. If you don't, just work with this one here, okay? So let's look at this here for a minute. I'm going to look at CO2. Let's take a look at carbon dioxide. And so when we're asking that question, okay, and you know what, I'm going to go ahead and I'm going to call it my smartboard, because I get to use the multiple colors and I think you guys enjoy that too. All right, so here we go, CO2. So what's our goal here? We're looking at percent composition, and this is by mass. So what's the percent of carbon and what's the percent of oxygen by mass? How much they weigh? Well, I need to know. I'm going to assume 1 mole of CO2. That just keeps it simpler, because in 1 mole of CO2 we know how to add that up together, right, boys and girls? The grams per mole thing. So we know that a carbon is 12.01 grams per mole. Okay, we get that from the periodic table. We also have 2 oxygens, each one being 16, right? 16 grams per mole. And we can add those up together, because that's what we're trying to find. What is our whole? See these? These are parts. We're going to add them up together so we can get ourselves that whole. Okay, so 0, 1, 2 and 6 is 8 and 6 is 14, 1, 1, 2, 3, 4. So 44.01 grams per mole of CO2. Okay, now guess what, guys? This is our whole right here. Now we need to look at the parts. So we got one part. Let's look at the part percent carbon. Well, that's going to be 12.01 over 44.01, and we're going to multiply the whole thing by 100 so we get the percent. Don't, for the love of anything decent, don't hit that percent key. You hit that percent key, your numbers will be messed up and you'll be wrong. Okay? Don't hit the percent key. Don't. Okay, hey, let's check this one out here. Ooh, got my handy dandy calculator. 12.01 divided by 44.01. Okay, and I'm going to multiply it by 100. Hey, before you do anything with those decimals, do the multiply by 100, okay? So I walk away with 27.289%. Now, I did say to you guys that let's round it to 2 decimal places. 27.29%. And that, ladies and gentlemen, is the percent of carbon in CO2. Okay, that'll work. Now, remember, if there's something you don't totally get on this, you can either reverse this and go back, but there is also my stoichiometry playlist on my other thing, okay? This is kind of like a special edition here for the remote learning. All right, let's take a look at the percent oxygen, okay? Well, we know that the percent oxygen is going to equal 32, because remember, it's 2 of the 16s together, over 44.01, and again we're going to multiply by 100 to get that percent. Don't hit that percent key. It is the most useless thing on a calculator for us. 32 divided by 44.01 and times 100 equals, and I have here 72.71% oxygen by mass. Well, hey, let's take a look at this. How do I know that this is right? Well, they should be adding up to 100 or something really super close. So let's see, 27.29%, that's for the carbon, and then we have oxygen here, 72.71%. Okay, let's look at it. 9 and 1 is 10, 1 and 2 is 3, 3 and 7 is 10, 1 and 7 is 8, 8 and 2 is 10, 1 and 2 is 3, 3 and 7 is 10. By the powers of Addison Rae, TikTok, it's 100%. Oh, glory. How? What do you know? So it does add up. It is correct, ladies and gentlemen. So with that, here's the thing. What did we cover? We talked about percent composition, where we were looking at, hey, how much by weight does each element take up in a certain compound of something? We looked at water, for example, how much was hydrogen, how much was oxygen, and then we also tore apart, whoa, heidi-ho, I'm messing with things out here, okay? We also did the same thing with carbon dioxide, part over whole. And with that, hey, I hope this video finds you well, guys. You take it easy, you're not alone, God's in control. Take care.